All right, this thing on? Perfect. Good afternoon, everyone. Thank you so much for joining me here in this slightly warm room. So glad you could all join me. Before we get started, a quick show of hands. Who is here just to see Doom on a big screen? Couple? Who is here for the actual technology behind this talk? All right, that's good. That's good. At least something. Um, you know, I was just talking to the good people here at the table. It's like, why didn't you just ask AI to make this port? And funny enough, we actually did. So I asked AI, or ChatGPT in this case, can you port Doom to .NET MAUI? Can you do that for us? It responded with, yeah, well, the porting is difficult, but these two guys actually did some effort on this. Maybe you should contact them. I don't know if you know who I am, but I'm one of those two names. The other one is sitting over there. Not a lot of help, this AI thing. Anyway, so we did it manually. How did all of this get started? How did I end up here talking about an ancient game? This is the question that started it all. Again, responsible person over there. Who has seen the session about the history of video games by Wesley? All right, it's his fault. Blame him. So he came to me like, hey, you know what would be fun? This game, Doom, is open source. I'm working on porting it to WPF, he said. It would be fun if you could try to put this on MAUI, because I was doing a lot of MAUI development. So I cleared my schedule, and we went to work. Took way too long. I spent evenings, a couple of months, and we ended up with a working version. So the version that you saw running when you came into the room, that's the .NET version that Wesley mostly created. It's WPF running Doom. And this is why I want to set expectations a bit. This talk is not about me porting the C code all the way up to .NET MAUI. This is me taking Wesley's port, which was already .NET, WPF, and putting that into MAUI. So basically, this is a talk about how to take a .NET desktop application and put that on cross-platform mobile devices. That's what this is about, just to make sure that we're all on the same level. With that said, again, good afternoon. Nice to meet you all. My name is Nico. I'm an application architect from Belgium, where I work as a consultant at a company called NET MAUI. I've been a Microsoft MVP since 2014. I co-run the Visual Studio user group in Belgium. I'm also part of a conference crew there called Tekorama. I wrote a couple of books. None of those matter anymore. So if you want to buy them, feel free, but nothing to be learned from there. I brew my own beer. I play guitar. I ride a bike. I don't do all of these things at the same time. If you want to follow me on socials, I'm on Twitter, I'm on Mastodon, I'm on Threads. It kind of depends on what mood I'm in to see where I'm mostly active. But feel free to give me a follow if you have any questions after this talk or in the coming days. Feel free to reach out to me. I'll be happy to help. Now, who here has done MAUI development? A couple of people. Who has done Xamarin? A couple. OK. Now, who has never heard of MAUI? Everyone has. OK, that's perfect. Now, when I'm talking about MAUI, I'm not talking about this one, not the island in Hawaii. That's not what we're talking about. It does have the same name. There's an island called MAUI. It has the same name as the multi-application platform UI thing. And if you search for MAUI online, you find a lot of information about the island, not about the platform, which is a problem. But if you go looking for problems with MAUI, that's when you find .NET MAUI. So there's a hint on, on that. Kidding aside, what is .NET MAUI? .NET MAUI is cross-platform .NET applications. You write your code using C#, using XAML for the UI, or C# for the UI, which you can do as well. And you can run your application on iOS, on Android, on Mac, on Windows. I think there used to be Linux, but that's out currently. That's not available anymore. Biggest advantage of MAUI over other web-based frameworks is that you actually get the native controls of the platform. If you create a text box in MAUI, you will get the native Android text box on Android, you will get the native text box on iOS, you will get the native text box on Windows. That's how it works. How does it work under the hood? There's the different operating systems at the bottom. On top of those are the runtimes, which is the .NET Core CLR for Windows, since it's targeting WinUI 3. And it's the mono runtime over Android, iOS, and macOS. On top of those runtimes sits the .NET base class library, the BCL. And on top of those are the .NET abstractions, which is .NET for Android, .NET for iOS, for Mac, and then WinUI 3. Since WinUI is already written in C# and in XAML, there doesn't need to be a translation between those platforms. So it just works. On top of that is the biggest abstraction, which is .NET MAUI. And this is the place where the controls live, where the APIs live. So everything that is available on all the underlying platforms is abstracted into .NET MAUI, where you can just call it, and it will translate into the native API calls. On top of that .NET MAUI layer sits your own application code. So that's where, in this case, Doom will be running. Okay, this talk is very little slides, a lot of code. So what I did to prepare this session is, once we got a working version of Doom on MAUI, I went on the GitHub, I went through all the commits, I replayed them, and that's basically this session. So I'm going to replay a lot of those commits. I took out the most interesting stuff, the technically most interesting stuff. There's a bunch of snippets in there. I will paste some code in there, and I will explain the things that we ran into and where we found some issues. All right, let's do this. Let's switch to Visual Studio. Let's zoom in a bit. Does it come through? Okay, okay, perfect. This is a solution. There is no MAUI to be seen yet. This is just the WPF solution. There are two projects here. The Windows project is WPF. The core project is a .NET class library. In the core project, this is where the Doom engine lives. This is everything needed to go over the logic that actually runs the game. Everything starts with the Doom game class, and I should have already increased my font size. Let me quickly do that. Sorry about that. Is that big enough? People in the back? Yes? Perfect. All right, so Doom game is where everything starts. This has a run method, and the run method is basically the entry point. This is where everything kicks off. First thing it does is it tries to identify what version of Doom you are running. And it does this based on a WAT file. Now, WAT stands for where's all the data? And it's basically a small container that contains the assets for the game. And it looks for the file name. So there's a Doom 2, which is a commercial version. Doom U is a retail version. Most of us will have played this one, which is the shareware version. This is also the one I'm using. The WAT files are also the reason that we cannot publish this game, because the source code is open, but the WAT files, you need to find those for yourselves. So we can publish the source code openly. It's on GitHub. I have a link at the end. But you won't find the WAT file there. You need to find it for yourself. All right, so it checks which of these exists. That's the game mode it will start, and that's the file name it will add. It will load in the WAT file, it will prepare everything, it will start a game loop, and you're up and running. And this is immediately one of the first problems we had with MAUI, because this is accessing the file system, which is easy on Windows. We got all the Win32 APIs to access a file system. It's not so easy on mobile devices, because those are more sandboxed. That's one of the first problems we had to work around. So where does it look for those files? If you go into the launch settings of the WPF project, there's a variable set here, and this is the path where it will search for it. All right. Second part is in the WPF project. Let's start with some XAML. This is all the XAML there is. This is basically an image control. And it's bound to a property on a class that's called the main view model. This is by no means a decent MVVM setup. It's just something called a view model. You should have done MVVM better, Wesley. So the output, let's go to the main view model immediately. The output is a writable bitmap. And every X amount of time, every frame, we put a new image into that writable bitmap. The binding system will take care of updating, and you get a fluent running game on screen. So we're just replacing bitmaps all the time. There are two methods in this view model that take care of everything. There's the update palette, which will make sure that the palette of all the colors we need is prepared. And then there's the screen ready, which will create basically the bitmap. It will fill up the bitmap with all the necessary pixels, all the right colors. It will put it in the output right here, and that will get rendered on screen. All right. With that, let's add a new project to the solution. And we will be using a .NET MAUI app that we will name doomsharp.maui. This is .NET 8. I think we originally started in .NET 6, and then we just kept going up, which worked quite well. All right, we have a MAUI project. Let's set this as a startup. Let's build that, and while it builds, let's have a closer look. So for you, those of you who have ever done Xamarin but no MAUI, this will look different. In Xamarin, you had at least 3 projects in your solution. You had your shared project containing all your shared logic code, and then you had a project per head, per target, iOS, Android, Windows. Here, with MAUI, they've done some optimizations. It's still the same system underneath. They're just not showing you 3 projects anymore. It's one project. It has a platforms folder. And in that platforms folder are all your different platforms that you want to target. Within those are, for example, your main activity, your main application, for those of you who know Android. These are actual starting points. These folders are also where you put your platform-specific codes, of which we have none in this talk. Then there's the app.xaml, which is the startup point of your MAUI application. There's the app shell, which starts up your shell environment, which means the hamburger menu, the title bar, all that. That's called the shell. And then there's the main page, which is the first page that will actually get rendered. Build succeeded. Let's see if this runs. Oh, by the way, if you want to run on different targets, you can just use a drop-down and select whatever. For the sake of speed, I'm using Windows as a target, meaning that everything you will see will be using WinUI 3 to render. This is just because compiling to Windows is faster in MAUI than no matter what different platform. And just to run it, I don't need emulators. Emulators kind of suck, so that's why. Let's see if this runs. There we go. We got MAUI up and running. There's that. OK. Next up, I'm going to take the view models folder, let me show you, from the WPF project, drop that onto the MAUI project, take out the console view model that does some logging. I don't need that. And take out this one here. There we go. We got a view model. Close this. All right. Next thing we need is we need to be able to access our core, our Doom engine. So we need to add a reference to that project. Funny thing that apparently very few people know, you can just drag and drop to add references. Who did not know this? You didn't? Nice. So just to prove it, let's just go like this, add project reference, it's selected. So you can just drag and drop them. If there's anything you learn from this talk, let it be this. It's the best part of it. Okay, let's see, where are we? I need to go to the app.xaml.cs because we need to have a static property for our view model locator. Thank you, Copilot, but you always get the name wrong. You would think after giving this talk 9 times, he would know how I want my view model locator to be named. Apparently not. So AI is not taking over the world just yet. Okay, going to the main view model, this is where the real problems began. For example, writable bitmap, which we depend on greatly. It does not exist in MAUI. So we needed to find a replacement. First thing I tried, there's a Win2D API in MAUI. I tried using that one, but that was not sufficient. It didn't have the necessary APIs to make this an easy port. So we continued looking. And we ended up with a little NuGet package called SkiaSharp. So SkiaSharp is the .NET version of Skia, which is a Google library that deals with imaging and 2D graphics. So let's install SkiaSharp. And then there's a second NuGet package called Views MAUI Controls. And this has some controls that you can use in MAUI where you can actually render your Skia bitmaps. There's a canvas view in there, and that's the one we will use. Okay, let's let that restore. And then also something new in MAUI compared to Xamarin is the fact that they now also use the app builder pattern, similar to what ASP.NET does. In the MAUI program.cs, there's a create MAUI app method which creates a builder, and then you can use whatever way of working. You've all seen this, right? You can use the same thing now in MAUI, and we need to use SkiaSharp. If you forget this, you will get really strange errors that make absolutely no sense. It's just Skia saying you forgot this line, which would have been an easier message, but hey. All right, going back to the main view model. Let's close all the other tabs, do some housekeeping. We are replacing writable bitmap with SK bitmap. Go away, resharper, I don't need you. But like this, we're going to skip this one for a while. This one is also SK bitmap. Don't need this. This line, application current dispatcher invoke. Whenever you're doing native front-end development, you want your changes to the UI to be done on the UI thread. If you're not on the UI thread, things will crash. Because you're trying to update things that live on another thread from a different thread, that's no good. So a way to make sure in WPF that you are on that UI thread where all your XAML is living is using the application current dispatcher. Your dispatcher means you can take a bunch of code, dispatch it on the correct thread, and just run it there. The method used in WPF is called invoke. Invoke does not exist in MAUI. It's called dispatch. But exact same thing, just a different name. Going to comment this out. Going to use dispatch here as well. This is where we actually update the bitmap, but since we're doing SkiaSharp now, there's a different way of doing this. And it is bitmap equals sk bitmap.decode, and we pass in the byte array. There we go. Couple of errors left, mostly using statements. There we go. Only thing left now is the int32 rect, which is a built-in class in WPF again. We don't have this in MAUI, but it's quite simple. And I have a snippet here that will just copy-paste somewhere at the bottom. There we go. It's basically just a struct with x and y coordinates and a width and height. It's a rectangle. That's all it is. With that, my view model is now all green or yellow, some warnings left, and things should compile. While things are compiling, I'll be copying my next snippet. which is the XAML. So this is all the XAML in your basic main page that you get when you use the MAUI template. We don't need all this. Actually, just going to replace the entire page. I'm going to create this event handler. Relax. There we go. So what do we have here? There's the SK canvas view. This one is coming from the SkiaSharp views MAUI controls library. This is the Skia canvas. This will accept the Skia bitmap and will render it. That's what it does. Notice that there's no binding here. This does not support binding to a Skia bitmap directly. We need to go through the paint surface event that will fire every time that the surface is invalidated. For the rest, I have a bunch of game controls. Game control doesn't actually exist yet. It's a class that we'll paste in a second. Why is this here? Because MAUI is meant to be run on devices with touchscreens, meaning we need virtual controls. We have no keyboards. We do have a keyboard on Windows and Mac. We'll get back to that. For now, we're focusing on virtual keys. So we need keys drawn on screen, virtual buttons. If you press them, things need to happen. With that, I'm going to take a folder here and paste it in here, replace some files, and game control now exists. What is game control? It's a simple class that inherits from image. It's a basic image. Right? I have a bunch of PNGs that contains all the little buttons, the arrows, action buttons, and whatnot. So basic image. I also need to have a key. I need the system to know what key I pressed. So that's why I have a property called key. That is that. I have some duplicate resources now that I need to remove, which is these two. There we go. I also broke something now. So this is WPF code again. And this is the main window of the WPF code. And this is where the application will start. This is where it creates a Doom game instance and calls the run method. You remember run? I showed this at the beginning. This is where everything starts. Now, run, I've shown you this. You have the identify version methods that goes into the file system, which we can no longer do. So with the code I pasted in, this has been replaced by run async. And run async now has an overload. So there's the same version without any parameters that will keep the WPF version just running, because that was the goal from the get-go. The WPF version needs to keep working. So minimal changes there. Then there's the overload that takes in a game mode and a file name, which is basically the same thing that we get by running the identify version method. But we need to do this in a different way. To do that, I created an abstraction for the WAT stream provider. So this is a method that will go look for the WAT file on the file system. On WPF, using the Win32 APIs, on MAUI, using the MAUI APIs. So if you look here in the MAUI code, this is the WAT stream provider, and this will use filesystem.current.openapp package file async, which again is an abstraction on opening files on all the different mobile platforms. Let's see. I'm going to copy this piece of code, the piece that actually starts the game, and put that into our MAUI code. Oh yeah, we no longer need this one. This is for later. So MAUI has some overrides. One of them is on appearing, and this will trigger as soon as the page appeared. What's in a name, right? This needs to be async void, doesn't matter here in this case. And we run Doom async. If we run this now, this will not work because it has no WAT file, right? First of all, we need to actually add the WAT file into the package. So the file needs to be physically there. Building a mobile application means that you package everything into a container, and that container gets deployed on your device. Meaning the WAT file should be inside that container. We should include it with the thing that we push to our device. How do you get things, resources there? By using the resources folder. You can put your images there. For example, these are the buttons. Those are there. And then there's a raw file. And this is where you put everything else. Everything that's not a font, not an image, not something that the system knows. You can just put it in there. And it will copy it into the container and will do absolutely nothing with it. It will just sit there waiting for you to use. This is the place that we need. Going back to here, here's my WAT file. Come on. There we go. That's there. That exists now. Quickly flip the script and copy this. So this is an alternative version of the identify version method. And this one we'll put into the MAUI application itself. It does the exact same thing. It checks the file name. And then it loads whatever game mode that the file name represents. It loads the location of the WAT file, and that's that. But instead of just using the file APIs, it uses, again, the file system. App package file exists async. And this will just look inside its own container, inside its own sandbox. All right. Next snippet. There's the unappearing that we will increase a bit or improve. There we go. Okay, so unappearing will create a new task, background task that will be running. We will use the identify version method that will give us back a tuple with a game mode and a file path, which we pass into the overload of the run async method. And from that moment on, our Doom engine is working. It has a WAT file, it loaded it in through the abstraction, which we still need to initialize, and everything will start rendering. And as soon as on our main view model, the property changed event triggers, we enter this method, where we will check, is it the output? You remember the Skia bitmap? Did that property change? Then we will invalidate the game surface. And game surface is the name of the Skia canvas in the XAML. So by invalidating this, the system or the Skia canvas will trigger the pane surface event, and we will fetch all the data from the output property and just draw it on the canvas. That's that. I think we need just one more thing. Going to the app shell, we need to set WAT file collection dot init new WAT string provider. So the WAT file collection is again an abstraction. It needs the correct WAT string provider, which is specific to either MAUI or WPF. And then we need to Doom game itself to have an output renderer, which is our main view model dot instance. Let's see if this compiles. Build failed. Build failed, 0 errors. Awesome. Oh, there's that again. Copying in files and copying in snippets into MAUI, the system does not always like that and likes to break every once in a while. So what I just did was use a small tool that I built that will delete everything out of the OBJ and the bin folders, and that could fix it. If this doesn't immediately build, we'll just continue, and at one point it usually starts working. This happens all the time, don't worry. Let's give it a bit of time. While we wait, I'll start copying the next snippet. There we go. Since I've deleted everything, this takes a bit more time. Build succeeded. There we go. Should deploy quite fast, and if everything goes okay, we should see something. We see absolutely nothing. Which could mean we need to set the binding modes. Binding context is this. Did I forget anything? Oh no, this needs to be main view model dot instance, like that. Still nothing. That's okay. We'll just continue. It will start working at one point. Oh no, that's right. It shouldn't work yet because we commented out some code that we didn't replace yet. We're not done. So let's put in some new codes. Going to replace all of these with all of this. There we go. All right, so this changed significantly. What changed? The old version, and I will put up a slide to explain this. The classic version, the WPF version, uses index 8 images, which basically means that you have a palette of different colors, different pixel colors. The image that comes in that you want to show on screen does not contain actual pixels. It contains references to that palette, which is what you see here. The table on your right has indexes and colors, and then the matrix on the left, that one has references to those colors. And the system receives both values and will replace all those indexes with the correct color. That's how it builds its image. That's index 8 imaging. It doesn't exist in Skia, so we build a system ourselves. And this nested for loop does exactly that. So the palettes that we get here, this is the table containing all the indexes and the colors. And the output is the byte array that we want to use to actually build the screen. So this contains all the indexes, and we need to replace it with colors. That's what we do here. We have values for red, green, and blue, RGB. We set up pixels, and then we set everything to the output. And now that we're doing this, there should actually be some image. There we go. Now we're rendering. Let's wait for the demo to load. And I don't know if you can see this, but it's working, but it's kind of sluggish. It's quite slow. It's not as well. Doom has never been the most fluent game, but it should be better than this. I was looking for the reasoning behind this. But why is this so slow? Because our computers are powerful enough. The game is ancient. It should run. And we came to the conclusion that it is that the reasoning is this. This takes too long, especially because we're doing this managed. So we switched that to. That's not what I need. We switched that to this. Which uses the unsafe keyword. Now, unsafe, and I will explain to you in a minute what it does. Unsafe is a keyword that is disabled by default. You cannot use this. Unless you allow it in your project, ReSharper can do this for you, but it just adds a entry in your CSproj file, saying that you can use unsafe code. If you're doing unsafe, that means you're telling your garbage collector that whatever is in here, I got this, stay away. I know what I'm doing. Your garbage collector goes like, okay, this is on you. This basically means that you can use pointers. Now, to give credits where credits are due, I just asked Wesley to fix this for me because I don't know how to do pointers. So he did it. With that in place, things were starting to look up. But the way we rendered also needed to change a bit. Yeah, so this if and else, I will get back to this, no worries. So we also switched to using the Skia color class, and then we used unsafe to do, again, the nested for loop and create the image. What did I copy? Paint surface. Going back to the page, and this logic also changed a bit to this, and I think I forgot one here. This was just a bit of rework. There's nothing terribly exciting in the code that I'm now pasting. It's just some rework to make everything better. Okay, so I need to change this. This needs to become main view model dot instance dot bitmap rendered. No, come on. There we go. We need to use that one. This one can go. There we go. On 7 we did that. All right. If I did everything okay, you should see the game running again, and it should be much smoother after it builds, if it builds. So just to show you how volatile these kind of things can be, I was dry running my demos this morning, and when I got to the end and I hit build solution, the build would fail every single time. Weird errors, unfixable, restart Visual Studio and everything, it would just fail. If I hit the run button, it would compile successfully and run. If I closed it, build solution, it would fail. No clue. So software development, not an exact science. Let's wait a bit for the demo. There we go. This runs way smoother. I don't know if you can see a difference on the big screens. Big difference. Interesting side effect. I had this running on Windows, and I'm going to pull up the screenshots while we're at it. This was running on Windows, and I thought might be the time to have a look how this works on Android. So it built for Android, it deployed on Android immediately, but it looked like this. It worked perfectly fine, but it looked like this. And after some investigation, we found out that, going to the main view model, over here, for the Skia colors, the red value and the blue value were inverted. So that's why we have this code here. And these are your compiler predirectives. If we are compiling for the Android platform, then this code will light up. And if you look carefully, then you will see that the red value on every other platform is the blue value on Android, and vice versa. So with this this is ugly. With the hashtags and the ifs, that's ugly. That's ugly code. But this is the way to fix it. With that, everything worked perfectly and rendered perfectly. A way to check if your platform-specific code works is with the drop-down here. And here you can select which platform your IDE needs to interpret. If I select Android, notice at the bottom that the other line lights up and this turns gray. So that's how that works. All right. With that, we have our game running. At least the demo is running, but we have no touch input yet. The controls are there, the buttons are there, but they're not responding. So, going back to the XAML code, we see that we have game controls. But if you remember game control, that was just an image. So in order to do this, let's have a quick chat about how these controls work. So this is button, for example. Buttons exist on all the platforms, right? And if you look at how MAUI handles controls, at a complete bottom, wow, at the bottom you have buttons. And these buttons are platform specific. On the left, you have your UIKit button, which runs on iOS. And you have your UIKit button or UI button for Mac. You have the app compat button for Android, and you just have the button for XAML or for WinUI. On top of that are handlers. And these handlers, that's MAUI. So the bottom layer, that's native platform. On top of that, you have MAUI, which is basically a translation between the .NET code and the platform native code. On top of that sits an abstraction, because you still have 3 different ways. Because all 3 are buttons, but all the properties and the methods are named differently and work in a very specific way that is not compatible with all the other platforms. So there needs to be an abstraction, which is the I button that sits on top of that. That abstraction is implemented, and that one is called the button. And that's the actual button that we use in our XAML code, right? And the interesting thing is right about here, these things called handlers. This is .NET code. Handlers are .NET code. And we can append extra code to those handlers for us specifically. So we have an image here, or multiple images, and we want to add some functionality to those images. And handlers are the way to do that. So going back to the code, going back to my main page, going back to on appearing, I can just take my image handler and take the mapper and append to mapping. I need to give this a key. This will be touch support. And then it takes in the handler and the view. And it's as easy as that. So I'm taking the image handler. I'm appending to the mapping, meaning the mapping that will map the handler onto the actual control. And I add extra code to that. The parameters I'm getting is handler and view. And the view is the actual I image. Let me zoom in. So this is the I image abstraction that I can do stuff with. And the handler is the actual handler that I also can use. That's it. I don't have to do anything in XAML to make this work. This will just append my code that I will write in a minute to every single image control on this page. My game controls being images, that will just attach to those. Let's throw away this one. And there we go. Don't worry about the commented code for now. That will come in a second. My controls being images, but being a subclass class gives me the opportunity to check if I'm actually writing code against a game control. Because if I add images, just like, for example, a logo, that logo will also pass through this append method, meaning I'm adding touch logic to my logo, which I don't want. So that's why I'm doing some type checking. And then you have the platform view. If I zoom in a bit, you can see that the platform view is a XAML control. Now keep in mind that this might be confusing because both MAUI and WinUI are XAML-based platforms. But if the namespace starts with Microsoft.ui, that's WinUI, that's not MAUI. This is Windows native control that I have here. And I can attach to those events as well. So I have the key up and key down event. Now, why am I doing it this way? I know some people here have used MAUI, so you know about behaviors, and you can just add a touch behavior, and you can click an image, and it would just work. Yes, that's correct. But this is a game. And if I want my character to keep running, I do not want to do this all the time. I want to be able to keep the button pressed, which means I need both my key down and my key up event, which does not exist in MAUI behaviors. You just have your clicked or tapped or whatever it's called event. But in the native controls, that does exist. So that's why I'm using this. So I can go into the platform view and use key up and key down. I'm calling the onKey action method that does not exist yet. I'm passing in my control key. Control is my game control. The key is whatever I set to it, that's a press key. And I have a key up and key down event type. Again, on Android, this works differently because we are running against platform native controls. So for Android, this is differently. If you want to do iOS, that will be different. If you want to do Mac, that will basically be the same as iOS. So whenever you need to deal with platform native controls, you will need to do this for every platform you're targeting. That's the downside. All right. This is a long one. There we go. This goes into the main view model. Right about here. Close off the class. There we go. So this is the onKey action. This is the one method that you saw was missing. Now it's there. We translate the key into the correct integer value. That event gets added. Add event is here. So how the Doom engine handles input is that everything gets queued up. Every single action you do gets queued up, and they get interpreted one by one. They get dequeued. All of that logic sits here in the doomsharp.core project. So that's all there. All of that code was working from the WPF version. I just needed a way to capture the input and pass it to the engine, and that will do the rest. No logic needed there. So that's where this is for. And once it gets enqueued into the events, which is a queue of input events, every tick, it will try to dequeue it and post the event into the Doom game instance. And the engine will do the rest. Going back here, everything is lighting up nicely. Let's see if it builds. It doesn't because of this apparently. I'm just going to remove everything that's not Windows just to make sure and run this. There we go. Click the start button. We now have full control except for movement, but at least we can fire shots. So close enough. Okay, and with that, we had a full working game on mobile devices. But where would be the fun if we stopped there, right? Some of these platforms, like for example Windows and Mac OS, they do have physical keyboards. Why would I be clicking on a screen with virtual buttons if I have an actual keyboard? So why not implement keyboard support, like hardware keyboards? And that implementation, we did a bit naive, in that sense that we made the assumption that only Windows devices have physical keyboards. I know that iOS devices can have keyboards, Android devices can have keyboards, but forget about those, we just implemented Windows keyboards. So keyboard support in MAUI is there in a sense. Like if you have input controls, like a text box, then you can capture the key events. But we don't have a text box. There is no focus anywhere. We just need to capture all the events. And that just didn't exist out of the box. So we had to find a way around that. And the solution there was to make use of behaviors. And behaviors are yet another way to create an abstraction and a platform-specific implementation. So we have a keyboard behavior here that's not supported on Android, not supported on iOS. And it has two events, key up, key down. And then there's the Windows-specific keyboard behavior, which might look a bit complex, but it's not too difficult. Has anyone not ever done XAML? Just to make sure. Never done XAML, couple, okay. When you look at XAML, like a program running XAML-based layouts, it has a visual tree. The visual tree you can compare best to the DOM in HTML. So you have your different elements in there. There is a visual tree helper class, which you can see here. And with that class, you can actually traverse the visual tree and start looking for elements in there. You can find parents, children, and whatnot. You can search for them. The problem I was having, and that visual tree helper helped me solve, was that I'm in MAUI controls. These are abstractions. I'm very limited to the possibilities I have here. And none of the controls that I have allow me to actually attach key up and key down events like physical buttons to a control. That didn't exist. So what I needed to do was traverse the visual tree all the way to the top. And the final element you will find, that is no longer a MAUI element. That's native Windows, because that's the window where inside of it everything gets rendered. So I found the native window control all the way at the top of the visual tree. And that's a UI element. UI element is one of those base classes. And I call that root, and root has a key down and a key up event. So I'm all the way at the top. Key up, key down there, that will just capture all the keystrokes. So I attached those two events to invoke these two. And from that moment on, I could just create a new keyboard behavior. And I could attach event handlers to those two events. And that will be my final snippet right here. Let's see, right here is fine. There we go. And the only thing those two event handlers do is find the physical key that was pressed and again just push it into the on-key action, which is the same method that we've been using for the software keys as well. So we're reusing that logic. And then this is the part where all builds started to fail, except for deployments. So let's see. There we go. Deploy succeeded. Awesome. All right, let's press enter, press space. I'm just pressing the physical spacebar now. It's firing, this is working. I can now use my virtual controls, I can use my physical controls. I have a working game. Next thing we did was implement sound, which was also kind of complicated, but that part's not included here. If you want to check that out, that's on the GitHub. And let's switch back to slides for just a second. So what is the reasoning, what is the key takeaway behind this talk? First of all, it's an interesting use case to actually port a Win32 WPF application into cross-platform native MAUI lands. But that's just one piece of the puzzle. The key takeaway here is that software development is a very creative field. The skills that we all have can give us so much fun. Working on this project has cost me a lot of time, but it brought me a lot of fun as well. And it has brought me to different conferences as well, talking to you about it. I've had amazing conversations about the project that we did here. And this is just one example of crazy stuff we did. So don't forget to have fun with what you know and what you can do. And that actually is the key takeaway of this talk. Keep that in mind. Find something fun to do, find some friends, just go at it. And as soon as as all the fun stuff is done, you have no obligations to polish it and finish it and release it. Just move on to the next fun thing. With that, I will just leave you with the color green. keep this in mind as you walk past those boxes there. So just green. This is the link to the GitHub. I think we have about 6 minutes for questions, if there are any. See a lot of phones going up. Leslie, you have a question? You have a comment? All right.
Yeah. It's not a question, comment, it's just an addition. I ran into John Romero at a conference in Berlin, and I got him to play our version on my phone back then. So that was freaking amazing.
By the way, if you want to see the game running on an Android phone, feel free to come up to me. I have a medium-level Motorola phone. It's installed on there. I can show you, just to prove that it works. Any other questions or remarks? Nothing? All right. With that, thank you so much for joining me here. I hope you found this at least fun and a bit useful. Thank you so much.